Hey folks, let's solve some rational equations. First step, since I see fractions, is going to be to get rid of the fractions by creating a common denominator. So we are going to look for a common denominator. So 3p will be a common denominator. I just need to multiply this fraction by 3. So I need to multiply that fraction by 3, or the top by 3. So I get 12 over 3p. Equals, because these have a common denominator, I can add the numerators together. So I get p minus 2 over 3p. And now because we have that common denominator, I can just set the numerators equal to each other. 12 equals p minus 2, so I can add 2. So I get p equals 14. Number 2, what's my common denominator going to be? N squared. If I multiply the middle fraction by n, I can get an n squared there as well. So I would have n over n squared, but then if I bring down the rest of the equation, it's 4 over n squared equals my new fraction, which is n over n squared, plus this second or last fraction, 1 over n squared. So on the right side, now that I have a common denominator, I can add the numerators together. So I get n plus 1 over n squared. And now that I have the same denominator on the left and the right side of the fraction bar, I can get rid of it and just say, hey, 4 equals n plus 1. So then that means that n has to equal 3. There we are. Boom. Let's see, I have 2x squared, 2x squared, x squared. So if I multiply the left equation by 2 to get 2x squared, I will have the same denominator for all fractions. So I'll get 6 over 2x squared equals, let's simplify the numerator now. I can actually subtract those fractions because they have a common denominator. So x minus 1 is x minus 2. Now that I have an equation with common denominators, I can drop the denominators and just solve this equation. So that means that x has to equal 8. Number 4, I have a denominator of x squared, and x. So if I multiply that second equation by x, I'll get a common denominator of x squared. But what I do on the bottom, I have to do on the top. So on the left side of the equation, I already have common denominators, so I can subtract them. So I get 3 minus x plus 2. Now realize, folks, this is really like 3 minus x, and then that negative sign gets distributed to the positive 2, so it's also a negative 2. It's also getting subtracted away. So we get negative x plus 1 equals, on the right side, I have x over x squared. So I get negative x plus 1 equals x. Now I will add x to each side, and so I get 1 equals 2x. Now divide by 2 to get x by itself, you get x equals 1/2. Number 5. So what you could do is multiply all of the denominators together, but that's going to be nasty. So this is the same as 3n times n minus 1. Right? If I factor out a GCF there, if I factor all the denominators, I can see the different factors of it. And I see that this one is really 3n times n minus 1. This one's already got, did I do something? Yeah, totally scratch that. I can't factor a 3 out of there. This would be n times 3n minus 1. There. If I distribute that in, that's actually legit. So this denominator is missing the n. So I'm going to multiply it by n. And what I do on the bottom, I have to do on the top. This denominator of n is missing a 3n minus 1. See how it has the n part but not that factor part? So I'm going to multiply the bottom by 3n minus 1. and the top by 3n minus 1 in parentheses, because the 3n and the negative 1 are multiplying with the 3. So on top here we get 9n minus 3 over n times 3n minus 1 plus, I'm going to take this and shove it kind of up there. This equals that. Just don't want it to get too overlapped and be confusing. So this second fraction is n times 1 on top. And on the bottom we have that same common denominator, n times 3n minus 1 in parentheses, equals, again on the bottom this is the same as n times 3n minus 1. On top, I didn't need to multiply the bottom by anything, so I don't need to multiply the top by anything, so I just have 3n plus 18. So now before we can add these together now actually, because they have a common denominator, so I would get 10n minus 3. And then you're probably like, you know what, I can just drop the fraction now because we have that common denominator on the left and the right side of the equation. Oops, that's a plus sign right there. So now we can solve this equation. So I like to address the fact that there's n's on both sides right away by subtracting off the smaller coefficient. 3 is smaller than 10. So on the left side I have 7n, whereas on the right side I don't have any n's anymore. So now I can focus on just getting n by itself by undoing subtracting 3 by adding 3. And then I get 7n equals 21. So n has to equal 3. There we are. Number 6. Let's factor. So this denominator I can't factor anymore. The middle one I can factor out an a. So I get a times the quantity a minus 5. And same over here. A times a minus 5. So we almost have a common denominator, but this a right here is missing the a minus 5 product. So I need to multiply it by a minus 5. So now on top, again, this a minus 5 is multiplying with, both of those parts are multiplying with the 4. So I'm distributing the 4 in. So I get 4a minus 20 on top of a minus 5 times a. And you know, it's almost kind of silly writing the denominator down because we know we have a common denominator now, but it's just good to do. The factors on the bottom here I switched. I kind of like to keep things organized in the same, but I know it's not a big deal. I know it's a common denominator here. I'm talking about this denominator compared to that one. Multiplication is commutative, so I can rearrange it. So I can now add my fractions together, so I get 4a minus 19 equals a plus 2, and I'm dropping my denominators. Get rid of, a's are on both sides, so get rid of the smaller coefficient I prefer to do, but there are 3 other correct steps you could do instead for your first step. Add 19, and then divide by 3. So 3a equals 21, so that means a equals 7. Alright, a couple left. Alright, this one I can easily see that x squared is going to be my least common denominator. So I'm going to multiply this by x and this by x. Make sure you give this a hug because the x is going to multiply with the x on top and the 2 on top. So I get x, I'm going to multiply these together now because I will. X squared plus 2x on top of x squared equals x plus 4 on top of x squared. That was a bad looking 4. Plus x over x squared. So I get x squared plus 2x equal, and I'm going to drop the denominator because I have the same denominator for every single fraction. And so now I'll just simplify this. I can actually add these together because they have a common denominator, so I get x squared. Oops, just kidding. We're adding. So I have 1x plus 4 plus 1x. That makes 2x plus 4. Ooh. Now notice we have 2 different terms. We have x's and we have x squareds. So that means we're going to get a quadratic equation out of this, which means you want to set one side equal to 0. I like to keep a positive quadratic or squared term. So I'm going to subtract off 2x from each side. and I'm going to subtract 4. I'm trying to clear the right side out. So I get x squared minus 4 equals 0. So now if we can factor that, because factoring is one way to solve a quadratic if it's set equal to 0, or once it's set equal to 0. And this is factorable. X squared minus 4 is the same as x plus 2 times x minus 2, using your difference of squares. These are both values that I can square root. Square root of x squared equals x. We're subtracting another square. The square root of 4 is 2. So check this out. This is equivalent to that. If you multiply it together, you get the same thing. But now I know that this gives me a solution of x equals negative 2, because negative 2 makes this become 0. 0 times anything is 0, so it makes the equation true. And if I use this factor, positive 2 makes this factor equal 0. If this all equals 0, because 2 minus 2 is 0, 0 times anything is 0. So these are my two solutions, but sometimes you'll see that written as plus or minus 2. Positive 2 is an answer, so is negative 2. Last one. 4x squared is going to be my least common denominator, because I see that this has a 4x squared. This just needs to be multiplied by 4. This needs to be multiplied by x. And now I'll add my fractions. Ooh, this needs to be multiplied by, hello, x squared. Now we have 4x squared for all of our denominators. So I'm going to combine the numerators here since this fraction has a common denominator. So I get 3x squared plus 1. I'm going to drop the common denominators because they all have that. And so then the numerators I'm just setting equal to each other. And make sure this is a 4 because I have to multiply the top by 4 as well. Now let's set this thing equal to 0. Actually, this one we could solve. Right? I'm missing that middle term, that x term. So I can actually get this thing solved by just undoing things. I get x squared equals 1. Now we're not done, folks. We want to know what x equals, so we have to square root. Now remember, when you square root, what's the square root of, for example, 25? It's 5 and it's negative 5. What's the square root of 1? It's 1. It's positive 1 and negative 1. That means, folks, if you plug in positive 1 up here, the left will equal the right side. If you plug in negative 1, the left side will equal the right side. There we go. Nice job.